Alright guys, so the final video for this topic. So the first thing we look at is piecewise functions. So we had a quick look at them before, but now that you know the shapes of the graphs, it'll make much more sense to you. So as you can see, piecewise functions is just made up of different graphs in different domains. So here we can see that between -5 is less than x and less than or equal to -2, we can see it's the equation minus x minus 5, which is just a straight line with a negative gradient. Between -2 and 2 is the parabola, -x squared plus 1, so you can see it's a parabola there that's shifted up 1. And then the last part is just the cubic. So you can see it's a basic cubic that's being shifted to the right 3 and up 2. So that's the center of the cubic. And you can see it's just a basic cubic shape. So yeah, I hope this makes much more sense to you now. See, I've added some questions here, but I'll let you guys do them yourself, as you should be able to do them pretty easily now. But yeah, I just wanted to do number 4 and 5 with you because it's a bit different and it's kind of cool. Alright, so let's look at 4. See, I'm going to show you a different way to analyze these graphs. Alright, so we know it's going to be an absolute value graph. So I'll draw that in. And then it's also going to be a graph -x. So we know -x looks like this. Alright, so I'll draw the result in black. Alright, so what this graph is, so I'll just move so you can see the equation. It's the absolute value minus, so it's the red graph minus the blue graph. So you can see here, it's pretty much the same number. So any number minus itself, so like 1 minus 1, 2 minus 2, 3 minus 3, all equals to 0. So this bit here, it's just going to go like that. Alright, that should have come out black, but it doesn't matter. And then what we have here is, so it's the red graph minus the blue graph. So it's like saying 1 minus -1, 2 minus -2. So you can see it doubles because 2 negatives make a positive. So 1 minus 1 gives us 2, so it'll be up there. To say 2 minus -2 would be 4. So it'll go up there. So yeah, that graph is fx equals absolute value of x minus x. Alright. So next I'm going to show you the other one. So absolute value of x divided by x. So yeah, so we can use this graph again, the two dotted ones, to analyze this. So any number divided by itself, we know is going to be 1. And also another key thing to note, so the first thing is x cannot equal to 0 because it's at the bottom. So that means there's going to be a hollow dot there at 1. We know that any number divided by itself is just going to be 1. And then any number here divided by itself but negative, it's just going to be -1. See, I thought I'd just show you these two graphs because they're pretty cool. Alright, so the last thing we need to learn for this topic is graphing and sketching regions. So yeah, just a quick review of inequalities. So we've got to graph x is greater than or equal to 2. Remember, before we just had a number line. And then greater than or equal to, so we had a solid dot. The arrow just goes that way. So this one pretty much goes from -5 down to 3. So you know how it goes. I'll just do a dodgy one. So it's equal to at this point, and it's not equal to here, so it's a solid dot, and it'll just be that region there. So now we're going to actually do it with proper graphs, so not just a line. So before we start, remember if it's equal to, it's a solid line. So similar how there's a solid dot, so it's going to be solid. So just think of all the graphs we've done so far have been equal, so always solid line. And it's not equal to, it's just a dotted line. Alright, some notation. So you might see the union sign. So more commonly these days you recognize it as and then intersection, think of it as or. See, so when we have to shade a region, first thing is we just graph the line or the graph, and then we test the point that's not on the graph, and then that'll determine if it's true, then we shade that area. If it's not, then we shade the other side. So yeah, let's look at this first one. 3x minus y is less than 6. So I'm just going to rearrange that because you know it's a straight line, and I like the form y equals mx plus b when I graph lines. So you don't really have to do this, but I'm just going to do this because I like it. And we want a positive y, so we times through by negative 1. So that refers to inequality. Alright, so think of it as a line y equals 3x minus 6, but it's going to be a dotted line now because of that. It's not equal to. So we know it's going to cut at negative 6. So to find the x-intercept, we let y equals 0. So it'll be 0 equals 3x minus 6. So if you solve that quickly, you'd get x equals 2. So no, that's what our line's going to look like. But now, to solve this inequality, we have to know the shade either the top side or the bottom. So you got to test a point that's not on this line. So an easy one to test here is 0, 0. So let's just test 0, 0. So we sub it into the inequality. So y is 0 is greater than, so 3 times x is just 0 minus 6. So 0 is greater than negative 6. So the point is there. So let's see if it's, so 0 is greater than negative 6. That's true. So that means that so what I normally like to do is I normally like to put a little arrow here for later on. So that means we've got to shade this side. So that means this is our graph of the inequality 3x minus y is less than 6. Alright, so this next one, remember a half is the same as writing square root. So think of it as y equals square root of 25 minus x squared. So you should know from your graphs that this is going to be a semicircle. You know the radius is going to be 5. So it's equal to, so it's going to be a solid one. So now we have to know if we're going to shade the outside or the inside of the semicircle. So you can test any point that's not on the actual line. So we can test this point here if we wanted to, if that was 1. So let's test 0, 1. So if y is 1, y is greater than or equal to square root of 25 minus 0. So that's going to be 5. So 1 is greater than or equal to 5. So we know that's false. That means it's not going to be in this region. It's going to be on the outside. So we're just going to shade the outside area. Alright, so the next question is worded a bit differently. So it's a bit more old style. But pretty much means it wants you to graph x minus 4y is greater than 0. So I've just changed it to y equals mx plus b if I want to make it easier to graph for both of them. So for the first one, you would have got y is less than a quarter x. So you know that this is going to be pretty much a straight line that goes through the origin. So we can label a point on it if we want. So just say at 1, if x equals 1, y would be a quarter. So let's test a point that's not on this graph. So let's test let's just test that point there. So let's just test 1, 0. So that'll be 0 is less than a quarter. So we know that is true. So that means you're going to shade everything on that side. Alright, so for this other line, y is greater than negative 4x. We know that's a line that also goes through the origin, but with a negative gradient. So it'll be something like that. And if x equals 1, y would be negative 4. So yeah, let's test the point. So let's test the same point, 1, 0. Alright, so they're subbing the point, so 0 is greater than negative 4. So we know that's true. So just do a little arrow there. So we're going to shade everything on that side of the line. Alright, so that's part 1 and 2. So part 3 now, it wants the intersection of them. So now if we look above, we said the intersection is all. So that means it's the bits that they have in common. So if we were to graph these two on the same graph, so I'll just do that quickly now. So remember how we had the arrows going that way and that way? So now we want the common part. So it's going to be this section here. So that's the part where the shaded regions intersect. So the last part, we're pretty much going to draw the same lines again, but then we're going to shade every region, or both of them. So yes, I probably should have done it in a different color. So now we want to shade the bits that are common for this line. Well, not common, but the region for this line. So that'll be that bit there. And also for the second line, so everything down here, so it'll be this area again, but also be the bit down here. So that's intersection is and always everything. So everything that you need for that section. Alright. So now this is similar to the last one, so we're going to sketch these three sections on the one line. So first we'll draw our axis. So x is greater than 2. So you know the line x equals 2 is going to be something like this. And we want everything to the right of it. So we're going to get that area. Y is greater than or equal to 1. So you know that's your y equals 1 line. And everything above that. And y is greater than x squared minus 1. So you know x squared minus 1 is just your parabola that's been shifted down. And then quickly, if you want to work out the x-intercepts for this graph, let y equals 0. Let y equals 0, yep. So you get x squared equal to 1, and x equals plus or minus 1. Wait, sorry, so this line should have been solid because it's equal to. So this graph here is also equal to. So now we want to find if we're going to shape it in the inside of the parabola or the outside. So let's just test 0, 0. So 0 is greater than 0 squared minus 1. So 0 is greater than negative 1. So we know that's true. So that means we've got to shade the bit on the inside of the parabola. So yeah, so since this is an AND question, so we've got to shade the bit that relates to all of them. So yeah, we want the bits above the line, inside the parabola, and on the right of x equals 2 line. So it's just going to be this little section here that needs to be shaded. Alright, so for this final one, just think of it as two graphs. So if we broke this down, we get negative 1 is less than x plus y. We get x plus y is less than or equal to 1. See, I'm just going to swap sides. So x plus y. So when you swap it around, you got to switch the sign. So this one you get y is greater than negative x minus 1. And this one, y is less than or equal to negative x plus 1. So yes, let's just graph the lines first. So negative x minus 1, so it's going to cut down at minus 1. And it's going to have a negative gradient. It's going to cut at, so when y equals 0, x would be negative 1. So notice how these two lines both have negative x. that means the gradient is the same. So we know that these lines are going to be parallel. And this one, just go there, cut it one. It'll be a solid line. So let's just test 0, 0 for both of them. Because 0, 0 is in the middle and it's not on the actual line. So you get 0 is greater than negative 0 minus 1. So 0 is greater than negative 1. So no, that's true. So it'll be there. And for this line, let's test 0, 0 again. So 0 is less than or equal to 0 plus 1. So 0 is less than or equal to 1. So we know that's true. So that means the region in common is just going to be in between those lines. So I'll just change color. So yeah, that's what this region should look like. So yeah, thanks for watching. That's the end of this topic.